FreeCAD is unusable shit. This piece of garbage can't even perform the simplest tasks like an extrusion. It sucked, big time. You honestly should be ashamed for trying to rope people into that horrible experience. The UI is terrible and convoluted. It's slow, it's laggy, it crashes. Crime against humanity. Not worth wasting time with this tool.
A short answer to those comments would be skill issue, but that is not very productive. That's why in this video I'm going to share some tips and settings to help you understand FreeCAD better and use it more efficiently. Before diving in, you need to understand the core logic of FreeCAD. Everything revolves around workbenches. Think of it like a giant toolbox. All your tools are sorted and stored in different compartments. To complete a project, you'll often need to move between these compartments to find the right tool for the job. This is why it's crucial to differentiate between the workbenches used for building your model and the ones used for processing and outputting your work. To design your model, 90% of the time you will use the sketcher, PartDesign and part workbenches. The other ones, such as curves or surface, are used for more complex modeling. Once you have finished your model, you can use it in a process workbench, such as CAM if you want to generate G-code for a CNC machine, FEA for mechanical or thermal analysis, or TechDraw if you want to create technical drawings. The real beauty of this workflow is its parametric nature. If you reach the process stage and realize you need to change a dimension or a feature, you don't have to start over. You can simply jump back into the design phase, tweak your sketcher or any other workbench, and the changes will ripple through to your final model. You can see that I have highlighted the sketcher in red because I consider it the foundation of everything. Unlike software like Blender, where you model by directly pulling and moving points, here everything is controlled and parametric. It is driven by dimensions and constraints. That's why it's essential to have a two-dimensional vision of your object in order to create it. To transform these sketches into solids, you can use either the PartDesign or the part workbench. They can be used independently or combined, and I believe this is where the real difficulty lies for beginners or newcomers. On paper, they share most of the same tools, like extrusion, revolution, loft, or fillets, but their fundamental structure is completely different. For example, if you perform an extrusion on a solid in PartDesign, the extrusion is added directly to the body, resulting in a single solid object. However, if you do the same in the part workbench, you will end up with two distinct solids. To get a single object, you would then need to combine them using a Boolean operation. The same applies to removing material. PartDesign handles it automatically, whereas in the part workbench, you have to manually perform an additional Boolean cut operation to achieve the same result. A second major difference is how your objects are managed within the tree view. Depending on the workbench, the logic behind how they are stored and organized is completely different. When your object is created in PartDesign, all operations, sketches, and construction elements are placed inside a body container. The operations are then listed chronologically in the order they were created, and under each operation, you will find the sketches that were used to build it. This provides an excellent classification system, making it easy to navigate and find your various operations quickly. When your operations are created with the part workbench, the tree view is different. All your operations are stored inside the very last operation you performed. In our case, it was a cut. Inside this cut, we find our two extrusions, the original cube and the cylinder used for the hole. You can see that the sketches used for each are stored within their respective operations. For a simple case like this, it's easy to manage. But on a more complex project like this bike stem, it can quickly become impossible to handle without a proper method. Here, for example, if I want to find the very first sketch I made to change the height, I have to play a game of Russian dolls, opening every single operation one by one to finally find the precious sketch. It's an enormous waste of time. In parallel, I also modeled this same part in PartDesign. Since the operations are organized differently, I can find my sketch and edit it directly, without wasting any time. This type of tree view is the one most commonly used by other commercial software like Onshape, where your operations are listed in chronological order. That's why, if you are a beginner, I recommend focusing on PartDesign for your creations. It uses a modern approach, you'll feel much less lost, and it will save you a lot of frustration. However, if you want to tackle advanced surfacing, PartDesign simply won't cut it. You'll have to dive into the part workbench and others. In these complex scenarios, success comes from jumping between workbenches to leverage their respective strengths. The key takeaway here is that you shouldn't view these workbenches as isolated islands. For instance, let's look at this box with the repeating teeth on the outside. I started in PartDesign by modeling the base with a simple rounded square. Then, still within PartDesign, I created a new body for the single tooth. To repeat it, I stepped out of PartDesign and jumped into the draft workbench to use the path array tool, using my original base sketch as the guide. Once the array was done, I went to the tree view and simply dragged and dropped the path array back into my main body. This created a base feature, which perfectly merged the array with my initial pad operation. After that, I went back to my modeling and extruded the walls. Honestly, I could never have modeled this box so quickly if I had stayed strictly within PartDesign. Now that we've covered the core logic of how FreeCAD actually works, let's tackle one of the most common complaints: the user interface. Your first contact with FreeCAD probably looked like this, either in this default dark theme or its light equivalent. But you should know that this interface can be greatly improved and modernized. But before we do that, let's take a look at how the interface is actually built. At the top of the window, you'll find all your essential tools, whether it's for creating a new file, switching workbenches, or accessing tools specific to your current workbench. For example, here in PartDesign, these are the features that will help you with your 3D modeling. Next on the left, we have the tree view. This is where the entire history of the operations used to build your model is stored. As I mentioned earlier, within PartDesign, these operations are organized in chronological order. Usually located on the right, we have the task panel. When no operation is selected, it often acts as a shortcut menu for common tools. However, when you create or edit an operation, this is where all the parameters are defined. For example, in this pad operation, you can see that this is the place to adjust the extrusion height and other settings. If you select a part of your model, for example this edge right here, the task panel will automatically suggest tools that are relevant to your selection. As you can see, it's proposing a fillet. It really acts as a smart shortcut, filtering out the noise to show you only what you can actually use. Below the tree view, you'll find the property panel. This is where you can access the data properties to modify your operations parameters, such as changing the extrusion height of the pad selected. However, you can also access these same settings by simply double-clicking the operation directly in the tree view. When working with PartDesign features, I personally recommend this method. Not only is it faster, but it's also much more visually appealing. Still in the property panel, you also have the tab view. This is where you can adjust the visual settings of your body, like changing the color of the part, or even modifying the thickness and color of the edges. Now, if you are in the part workbench, the menus look almost identical, but the task panel behaves a bit differently. When you create an extrusion, it still shows you the relevant settings, even if they differ from those in PartDesign. However, once the operation is created, double-clicking it in the tree view won't reopen the extrusion settings. Instead, it launches the transform tool. You lose that direct graphical access. To change your extrusion height here, you have to go into the data properties and modify the value manually. It's a subtle shift in workflow, but one you need to be aware of. Now that we've taken this quick but essential tour of the interface, let's dive into how you can actually customize it. With just a few clicks, you can turn it into something like this: modern and minimal. We often underestimate how much a graphic interface influences our perception of the software's complexity. And if you are not a fan of the dark side, you can also have it in light mode. Let me show you how to get this result. We're going to start by installing a new theme. To do that, go to the Tools menu and click on Addon Manager. FreeCAD warns you to use add-ons at your own risk. You can go ahead and click Continue. On this page, you will find a wide range of tools that can greatly improve your FreeCAD experience, from new themes to additional features. Here we're going to search for the open theme developed by Obelisk79. This is the theme I recommend the most because it comes in both a dark and a light version. To activate it, just click Install, wait for the installation to finish, and then click Close. Now we need to tell FreeCAD to use this theme. To do that, go to the Edit menu and select Preferences. In the General tab, under the Application section, change the theme setting to Open Dark or Open Light. Then click Apply at the bottom of the window. You'll then need to wait a moment for the theme to load. The colors will adjust in the background. The open theme also comes with preferences that change how windows are arranged, hide or show certain tools, and reorganize the workbench menu. So click Apply to apply these changes. Then click Apply at the bottom and OK to close the window. To make sure everything is fully activated, you'll need to restart FreeCAD, so click Restart Now. FreeCAD should restart and open on the BIM workbench window. The Open Theme Preferences automatically activated it, so just click OK on the pop-ups that appear. You can then reopen the sample file to see the interface changes. It already looks much more modern than the default interface, but we can still tweak it a bit. You'll notice the workbench drop-down menu has turned into tabs, which is more convenient, but it does take up more space. We can reduce the number of tabs to only the ones we use the most. To do that, go back to the Edit menu and open Preferences. In the left-hand menu, click on Workbenches. On the right, you will see a list of everything available. It matches exactly what you see in the main interface. If you're just starting out, I recommend unchecking Mesh, CAM, FEM, Beam, and Spreadsheet. You can also reorder them to put your favorites at the top. At this stage, we're really getting into the fine-tuning, but since FreeCAD offers this level of customization, we might as well make the most of it. When you click Apply, you'll see the changes happen immediately, and it frees up quite a bit of space in the interface. Next, let's take care of the navigation cube. Right now, it's placed in the top right corner above the task panel. That creates a visual offset and wastes some space, so we're going to move it. To do that, click on Display in the left menu, then select the navigation option. In the corner option, choose bottom right, then click Apply. The cube should move to the correct position. You can then click OK to close the window. We can make the interface even more minimal by disabling tools we rarely use or that can be accessed elsewhere. To do this, right-click on the menu bar and uncheck File, Edit, View, and Help. The last small adjustment we'll make to improve the interface is rearranging the toolbars. The tools on the far left are also available in other workbenches, and I like having them on the row above next to the workbench menu. To move them, right-click on the menu and uncheck Lock Toolbars. Then simply drag and drop the group onto the row above. After that, right-click again and check Lock Toolbars to make sure they stay in place. Now you have a clean, minimal, and functional interface. The tree view on the left is completely transparent, so you can see your 3D model through it. If that bothers you and you want the tree view fully opaque, just click the toggle overlay icon at the top of the tree view. This will make the panel opaque. The property panel might shift to the right. You can move it back underneath if you prefer. Now that we have our clean interface, let's move on to a second setting that's just as important. Before we continue, a quick message from our longtime partner, PCBWay. They're simply leaders in PCB manufacturing, 3D printing, and CNC machining. You just upload your file, select the options, which are very detailed and complete, and you get an instant quote. I've tested their service several times, and the results were always perfect. Right now, you can see this bike chainring they machined for me. The quality is flawless, the tolerances are spot on, and all of this for a very low price, even for small quantities. Don't hesitate to take advantage of their offer, especially since you get a $5 coupon on your first order. They truly are the perfect partner for your prototyping needs, or even for mass production. A huge thank you to PCBWay for sponsoring this video. Just like in a video game, you can adjust the quality of your model and smoothness of the viewport. Go to the Preferences menu, then Display, then 3D View. Under the Rendering section, this is where all the settings happen. The first checkboxes depend on your hardware. Here's a quick guide. If you have a low-end PC, check Use Software OpenGL. If you have a powerful computer with a dedicated graphics card, check OpenGL VBO. If your computer is mid-range, don't check anything. On screen, here's a comparison of the number of frames per second with and without OpenGL VBO. You can see that this setting makes the viewport usable. Without it, navigating would be much more difficult. That's why if you have a dedicated graphics card, I strongly recommend checking this option. Next, the render cache stores visual data to prevent FreeCAD from recalculating every face of your model each time you move the mouse. After trying all three modes, I didn't notice a big difference. I recommend leaving it set to auto, so FreeCAD can manage it automatically. The next setting is anti-aliasing. This is what smooths out the stair-step effect on the edges of your parts. The higher the setting, the cleaner and nicer the lines will look, but the more work you're asking from your graphics card. I recommend setting it to 2 or 4 and only using 8 when you're taking screenshots of your work. To enable this setting, you'll need to restart FreeCAD, then just click OK to close the window. If you're doing surfacing or solid modeling with complex shapes, your model might look a bit low poly in the viewport, like this bike saddle here, but don't worry, it's only visual. To fix this, go to the Object's View properties and adjust the deviation value. The smaller the value, the smoother your object will look, but the more resources it will use. So if your model doesn't look smooth enough, this is where you change it. Now let's focus on another tool that is absolutely vital to understand and master: the sketcher. When you start modeling in PartDesign, the first essential step is creating a new body. As we've seen, the body acts as the container for every operation related to your model. If it's not already there, just click the new body icon. You'll notice that when a body is created, a coordinate system appears with its 3 axes, 3 planes, and an origin. What's crucial to understand here is that every sketch must be attached to a reference. This can be one of the base planes, any flat face of your existing model, or even a datum plane that you've created beforehand. To create a sketch, click the New Sketch icon in the toolbar. In the viewport, you will see the 3 origin planes of the body appear. You need to select one to start drawing. The choice of plane is important. For example, if you want to perform an extrusion along the z-axis, that is vertically, you should choose the XY plane. That's exactly what we're going to do here. Just click on it directly in the viewport. The view will automatically rotate to be perpendicular to the plane. This allows you to draw your geometry flat, just as if you were working on a sheet of paper. Before we start drawing, let's take a quick look at the interface. Starting from the left, the first 3 icons are utility tools. The first one allows you to exit the sketch. The second realigns the view perpendicularly to the sketch plane, which is very useful if you accidentally rotate your view. And the third one is the section view tool. It cuts away any part of the solid that might be blocking your sketch. Since we don't have a solid yet, clicking it now won't change anything, but keep it in mind for later. Next, we have the drawing tools, which allow us to create the sketch geometry. You'll find all the basic shapes here along with sub-menus for different options. For instance, you can draw a rectangle using 2 points or by starting from its center. Moving to the right, we find the constraint tools. These are used to fix and anchor your sketch, preventing it from moving or breaking when your model recomputes. This is a critical part of the process, and these tools can be a source of frustration if not used correctly. After that, we have the edit tools for operations like trimming unwanted lines, creating fillets, projecting external geometry, or making offsets. Finally, the last few icons are visual tools related to splines, which won't be necessary for our demonstration today. Let's look at a concrete example. We're going to draw a rectangle with a circle inside. First, select the rectangle tool. To draw it, just left-click once. You'll see the 2 dimensions appear. By typing a value, let's say 80, the length locks in. To move to the width, simply press Enter or Tab, and then you can enter a value like 50. Now just press Enter or left-click to confirm the creation. At this stage, the rectangle's dimensions are constrained, but its position is not. If you click and hold one of the edges, you can see that it still floats freely in space. This brings us to rule number 1 in any CAD software: always fully constrain your sketches. Leaving them under-constrained is a major source of future problems and model instability. Generally, you constrain the geometry's position relative to the origin or the axes themselves. For instance, let's try to place the bottom left corner of our rectangle onto the origin, so the left edge sits on the vertical axis and the bottom edge on the horizontal one. If we try to simply drag and drop the corner onto the origin, you'll see it doesn't snap into place, and the geometry remains unconstrained. To fix this, we need a specific tool. Select the corner of the rectangle, then the origin point, and click on the Coincidence Constraint tool. Now our rectangle is perfectly sized and positioned. We used the Coincidence tool manually, but we could have created it in the right spot from the start using auto constraints. Let's delete this rectangle and select the tool again. This time, make your first click directly on the origin. Before you click, you should see a small red icon, a cross with a dot inside, informing you that a coincidence constraint is about to be created. Once you click and enter your dimensions, the rectangle will turn completely green right away, signaling that it's fully constrained. However, a word of caution. Sometimes, depending on how you draw, constraints can apply themselves without you realizing it. This can lead to over-constrained sketches or errors, so always keep an eye on what the software is doing automatically. For instance, if you use the line tool and start drawing too close to the midpoint of the top edge, a symmetry constraint will be created automatically. If you then try to set a specific dimension relative to the vertical axis, an error message will pop up telling you that your sketch is over-constrained. This is why you must always keep an eye on the symbols that appear near your cursor before you click. These small icons are telling you exactly which rules the software is about to enforce. Now let's place a circle inside our rectangle at his center. We'll pick the circle tool and give it a diameter of 20. To fix its position, we could simply give it a horizontal distance of 40 and a height of 25. It would be centered, but there's a catch. If we change the rectangle's dimensions later, the circle won't stay in the middle. To make it truly centered, let's delete those distance constraints. Instead, select 2 opposite corners of the rectangle, then the center of the circle, and apply a symmetry constraint. Now, no matter how you resize the rectangle, the circle will always remain perfectly centered. This is the power of parametric design. These are the core fundamentals of the sketcher: creating shapes, constraining them manually or automatically, and using logical relationships to build a smart model. However, I want to draw your attention to how you choose to constrain certain elements. There's a big difference between a sketch that is simply green and a sketch that is built to be robust and easy to modify later on. One area where FreeCAD sometimes struggles is determining whether a dimension should be positive or negative, especially during significant changes. In this example, I have a 100 mm gap between the origin and my rectangle, and the rectangle is 2 mm wide. If I change the spacing from 10 to 150, the 2 mm width might suddenly jump to the other side of the line. This is what we call constraint flipping. This behavior can be very disruptive if other operations depend on this sketch. My advice to avoid this is to use a variable for the main distance and define your thickness relative to it. By creating these logical links, you help the solver understand your intent and prevent the model from flipping. A very important tool is external geometry or external projection. It allows you to import edges or vertices from an existing solid directly into your sketch, either one you've built or one you've imported. For example, if I want to draw a circle exactly at the center of this existing shape, I can use the external geometry tool to project the outer edge. This gives me access to its center point. Then I simply take the circle tool and snap its center to that projected point. It ensures perfect alignment between different parts of your model. Another common error you will likely face is the famous "wire is not closed" message. FreeCAD doesn't like ambiguous contours. For example, if I have two rectangles joined together, trying to extrude them will trigger this error because of the shared line in the middle. To fix this, you must remove the central line to create a single continuous outline. Most of the time, this error happens because you forgot to convert a reference line into a construction line, or you have overlapping lines, or simply because 2 points aren't actually coincident. Always double check that your profile is a single clean loop before leaving the sketcher. If you want to go further and learn even more about the sketcher, I highly recommend this excellent PDF by Chris B. Although it dates back to 2021, the information is still very relevant today. I put the link in the description. One last piece of advice regarding the sketcher. Don't think of a sketch as just something you use for a single 3D operation. I'm talking about master sketches. Using a master sketch is a total game changer in your modeling journey. It allows you to centralize all your key dimensions and parameters in one place. For example, this bike frame is built around a single master sketch. If I change one value like the top tube length, it automatically updates the entire frame and every related tube. It's the ultimate way to keep your design robust and easy to modify. I actually made a full tutorial on how to create this specific bike frame. If you're interested in seeing this workflow in action, I'll put the link in the description for you. We've covered the technical ground. Now let's talk about some more general advice. The secret sauce. The first ingredient in this sauce is organization. Taking this bike frame as an example again, you can see in the tree view that I've renamed every single body to match the corresponding tube. This is crucial, especially if you don't want to waste time later when you need to make modifications. A project with 20 objects named body is a nightmare. Remember the Russian dolls effect in the tree view we saw earlier with the part workbench? Well, you can actually counter that, not only by renaming operations with explicit terms, but also by using folders. If you create a folder for your sketches and move them there even after you use a sketch for an operation, it will stay neatly tucked in its folder while also appearing under its corresponding operation. It's a powerful way to keep your workspace clean and make sure you never get lost in a sea of nested objects. However, this folder trick doesn't work inside a PartDesign body. You cannot group all the sketches of a body into a single folder, even if that folder is placed inside the body itself. Now let's move on to our second ingredient, the SubShape binder. In PartDesign, a body operates in its own isolated ecosystem. It's basically blind to any external objects. Take this bike fork, for instance. It consists of two separate bodies, the steerer and the legs. Now, if I want to trim the leg so it perfectly matches the shape of the steerer, I can't do it directly. I need to bring the steerer's geometry into the leg's ecosystem. This is where the SubShape binder becomes your best friend. It creates a linked proxy of an external object, allowing you to use it for operations inside your active body without breaking the software's logic. It's the secret to making different parts actually talk to each other. In this case, I imported the entire steerer, but to trim my tube correctly, I only need the revolution step, not the final pocket. This is the true strength of the SubShape binder. You can cherry-pick exactly which operation from the history you want to reference. With the leg body active, I simply select the revolution from the steerer's tree, click the binder icon, and boom, it's imported into my leg's ecosystem. Now, a simple Boolean operation is all it takes to get a perfect fit. Keep in mind, this works for almost anything, sketches, faces, or solids, and it's the key to making the master sketch concept truly work across multiple bodies. The third ingredient is add-ons. Now, we already saw the add-on manager earlier when we installed our theme, but it's much more than just a styling tool. It also gives you access to some incredibly powerful workbenches. For example, there's the fasteners workbench, which lets you generate bolts and screws in a single click. Real cavemen know what I'm talking about. Then you have the curves workbench, which is absolutely essential for 3D sketching and advanced surfacing. And if you're struggling with the integrated assembly workbench, which can be a bit temperamental at times, I highly recommend checking out two alternatives. First, there's Assembly 4.1. I used it to assemble this entire bike chain. It's incredibly stable once you get the hang of it. Then there's A2+, which offers a workflow that feels much closer to what you'd find in SolidWorks. These workbenches are total lifesavers for complex projects. The fourth ingredient is a big one. Be extremely careful with fillets. In FreeCAD, the Fillet Tool is probably the operation that causes the most headaches. It doesn't always behave the way you'd expect, and more importantly, it's very sensitive to changes. If you modify a sketch at the beginning of your tree, your fillets are often the first things to break because the software loses track of which edge was which. Always apply your fillets at the very end of your workflow and don't add them until the rest of the structure is solid. Now here is a bit of a paradox. In most CAD software, the rule is never put fillets in your sketches. But with FreeCAD, it's often the opposite. Sometimes the 3D Fillet Tool simply won't work or will break your model later on. So here is my advice. If you can avoid the 3D Fillet Tool by building the rounded edges directly into your 2D sketch, do it. It's much more stable. Of course, sometimes the solution just doesn't exist and you'll have to find another workaround, but whenever possible, bake your fillets into the sketch to save yourself from future headaches. Another critical point, you cannot create a fillet that is larger than the available thickness. For example, if I have a 5mm plate, I can't apply a 5mm fillet or anything larger. The software will just give up. If you really need that fillet to cover the entire thickness, you have to trick the software. Enter a value like 4.99mm instead of 5. Keep this in mind because in other CAD software, these limits are often handled automatically, but here you need to be smarter than the solver. Which brings us to the final point I want to discuss. The mindset. This is arguably the most important point of the entire video. I probably should have put it at the very beginning, but it's also the most sensitive topic. If you've made it this far, I think you're ready to hear it. My advice is this: don't let your ego get in the way. FreeCAD is a CAD modeling software, and let's be honest, this type of software, whether it's Fusion, SolidWorks, or anything else, is never easy to learn. Just because you master one program and struggle with FreeCAD, it doesn't mean the software is trash or broken. Think back to when you first started learning your current CAD tool. Remember how steep that learning curve was? Sure, you have a head start here because the core principles are the same, but the functions can behave differently. I remember the first time I opened Blender. I thought it was the worst designed piece of software in history. But with patience, I realized I was completely wrong, and that very software eventually landed me my first contract as a freelancer. So don't let your ego cloud your judgment and don't get discouraged if things don't click right away. FreeCAD is a wild beast that needs to be tamed. That's why on this channel I offer tutorials on various topics to help you on your journey. I truly hope this video helped you too. If you enjoyed this type of content, don't forget to like the video and subscribe to the channel. I'm really looking forward to reading your feedback in the comments. Thanks for watching.